Alright, as we continue in Chapter 4, the last topic we're going to look at is scatter plots, or a fit align to data, or line of best fit. With scatter plots, or lines of best fit, we have different types of correlations. So let's say we've got one correlation where if I were to draw a graph for you here, and get an x and a y axis and just plot a bunch of points. Say we had a point here, and the points are kind of scattered around, hence the name a scatter plot. And as you got a bunch of points, you can kind of see a general trend, and you can draw what's called a line of best fit to go through some of the points and try to keep about the same number of points above the line as below the line. So a line of best fit might look something like this. Okay. And as you look at this, the line increases left to right. So this would have a positive correlation or positive trend. And what that means, as one thing increases, so does the other. An example of that might be, say, the more food you eat, the more weight that you gain. That would be, as one thing increases, so does the other. Let's look at another one we might have here. Let's say we've got another graph here. We got some of the points scattered around, like so. And again, looking at the general trend here and trying to draw a line of best fit, or a trend line that goes through some of the points and keeping about the same number of points above the line as below the line, might have something that looks like that. Well, as you look at it left to right, it decreases. So this has a negative trend or negative correlation. An example of that might be, well, what that means is one thing increases, the other decreases. So an example of that could be, the more time you spend stretching, the less likely you are to get injured. So more time stretching, less injuries. As one increases, the other decreases. That would be an example of a negative trend. Well, what if we don't have a negative or positive trend? We could have a scatter plot that has points kind of scattered all over the place like this, where you can't really see a trend. In that case, you can't draw a trend line or a line of best fit. So this just has there's none. There's no correlation. Alright, so this is going to be the only example that we look at in this video. Let's take a look at it. The table shows the duration of several eruptions of the Geyser Old Faithful and the interval between eruptions. Make a scatter plot for the data, describe the correlation, and write an equation that models the interval as a function of the eruption's duration. Alright, so if we draw an x and y axis here to start this off. The x-axis is going to label the duration in minutes. So duration in minutes. The y-axis we're going to call the interval in minutes. So label that. Give this a title. I'm just going to call this Old Faithful Eruptions. And now I got to set up some intervals. Looking at the x-axis duration in minutes, I'm going to start here. This is going to be 0. Going to go up by, looking at the table, it goes from 1.5 to 5, so I'm going to go up by ones. So this will be 1, 2, 3, 4, 5. Looking at the y-axis, it starts at 50 and goes up to 100. So I'm going to go up by, I'm just going to go up by tens. So this would be 10, this would be 20, 30, call this 40, 50, 60, 70, this would be 80, 90, and I'll call this 100 up here at the top. Alright, so now I'm just going to start graphing these points. So at 1.5 it's 50, so 1.5, 50 is somewhere in here. 2 and 57 is about in here. 2.5 and 65 about right there. 3 and 71 about right here. 3.5 and 76 about in there. 4 and 82 about right there. 4.5 and 89 about right there, and 5 and 95 like up here. Okay, so I got this scatter plot created. I'm gonna just sketch a line of best fit here because we can kind of see there's a general trend. I'm gonna try to draw a line that goes through most of the points. And a line of best fit's not exact. Alright, so we've done that. We want to describe the correlation. Well, we have a positive correlation. And what that means is one thing increases, so does the other. So we could say as the duration gets larger, so does the interval of the eruption. Okay, so we could say something like that. We want to now write an equation, so we're going to look at writing an equation in slope-intercept form. Y equals mx plus b. So we're going to need to know the slope, we're going to need to know the y-intercept. Well, looking at this, it looks like it crosses the y-axis at about 30. So I'm going to say that the y-intercept's 30. Now we need slope. Well, we got some points up here in the table. I'm going to pick two. I'm going to pick this. These 2 points here. So that'll be my x1, my y1, my x2, and my y2. So I've got this point 371, and I got this point 482. So I can do the the y2 minus y1 over x2 minus x1, and that would give me 82 minus 71 over 4 minus 3, which would give me 11 over 1, so my slope's 11. So I can plug those values in. My equation would be approximately y equals 11x plus 30.